Hello class, this is Mr. Sutton, and today we're going to be doing skill 8. We're going to continue our discussion on slope-intercept form, and today we're going to be graphing from slope-intercept form. So make sure you have your notes out and follow along with me in your notes so you can be able to complete the IP. So on the notes, to graph equations that are in slope-intercept form, first we want to rearrange the equation, make sure that it is in slope-intercept form if it isn't already. So solve the equation for y. So remember that form is y equals mx plus b. So we want y equals, and then our x term plus or minus our y-intercept. So we want to then, after we have that, determine the y-intercept. So that'll be the b value, the constant that's added or subtracted at the end. And then once we have that, we plot that point on the graph first. Then we determine the slope and use that to plot our remaining points. So we can get our second point from there. So make the slope a fraction if it isn't already. Beginning at the y-intercept, use the rise number to travel up or down, and use the run number to travel left or right. Remember that slope, m, can be expressed as rise over run. So we use our numerator to determine how our slope moves on the y-axis, and we use our denominator to determine how our slope moves on the x-axis. So then we connect the 2 points with a straight line and use arrows. Okay, so let's do an example here. So this one is already in slope-intercept form. We can see we have our y equals our slope and then our y-intercept. So our y-intercept in this case would be -2. So we want to start there. And then our slope in this case is -3. So as a fraction, that would be -3 over 1. So we want to go from this point down 3, 1, 2, 3, and to the right 1, down 1, 2, 3, to the right 1. And we want to plot as many points as we can. So then in the other direction, we'd go up 1, 2, 3, and to the left 1. So up 1, 2, 3, to the left 1. Right, so we can see it as a negative slope, which is what we want because it is negative. And we're going down 3 to the right 1 each time. So then we draw our line through and put our arrows at the end. Okay. For this example, this is not in slope-intercept form because the y is not by itself. So we need to divide by 2 on both sides to get that in slope-intercept form. So then our y-intercept would be 3 and our slope would be 1. We have an invisible 1 in front of the x. So we start at y equals 3. That's our y-intercept. Our slope is 1, so we rise 1, run 1. And this is positive, so we're going in the positive direction. And then in the other direction, we would go down and to the left. So again, we want to follow the same pattern, make a straight line. So our line would look something like this. Again, we want to plot as many points as can fit on our graph to make sure our line is consistent, so that we're not getting off track somewhere down on a different part of the graph. Okay, so this one is also not in slope-intercept form. We need to move the x term to the other side, so we'll subtract 3x on both sides. And then divide by 2. So we get y equals, and then this -3x over 2 is -3/2 x, and then -8 over 2 is -4. So our y-intercept is -4 and our slope is -3/2. So we start at -4 and then we use our slope to plot our remaining points. So we go down 3, 1, 2, 3, and over 2. And we're out of room in this direction, so we'll go in the other direction. So now we go up 1, 2, 3, over 2. Up 1, 2, 3, over 2. Up 1, 2, 3, over 2. Until we're out of room in that direction as well. Oh, I think I got off somewhere. Yeah, because this should be 1, 2, 3, so this should be here. That looks better. Oh, no. There we go. 1, 2, 3. There. Alright, so up 1, 2, 3 over 2. 1, 2, 3 over 2. 1, 2, 3 over 2. There we go. And then draw our line. Going through, arrows on both sides. Okay. And for this example, this is in slope-intercept form. It looks like it's missing something, and that's because it doesn't have the y-intercept on the end. If there's no y-intercept on the end, then we assume it's a +0 situation. So that means our b value is 0 and our y-intercept is 4. So that means we want to start at y equals 0, which is the origin. And then our slope is 4, so we rise 1, 2, 3, 4. Run 1, rise 1, 2, 1, 2, 3. We're out of room there, so let's go in the other direction. Down 1, 2, 3, 4. Run 1. And then we're out of room in that direction as well. So let's go ahead and draw our line. Put the arrows on the end, indicating it's going forever in both directions. Okay. Now let's look at, these are special cases. So for this, when there is no x in the equation, it is a horizontal line and crosses the y-axis to the number the equation is equal to. When there is no y in the equation, it is a vertical line that crosses the x-axis at that number the equation is equal to. So let's look at some of those examples. So here we have x equals -2. So this would be a vertical line passing through where x equals -2. So it looks like this. So what this means is that at every single point on this line, x is always going to be equal to -2. So this is -2, 0, this is -2, 1, this is -2, 2, -2, 3, right? All of these points have an x value of -2. And then here, this is y equals 3, so that's a horizontal line. Y equals 3, so it looks like this. Right, so every y value here on this line is 3. So that is the line that is created. So we have 0, 3, 1, 3, 2, 3, 3, 3, 4, 3, right, so on and so on. So those would be the special cases. Okay, so you should have your Skill 8 IP to work on. I expect you to complete that in its entirety with the time remaining. And have it turned into me the next time I see you in class, right? So have a good day, and I will see you in a few days.